In lesson 1.2, we are going to talk about linear measure. And so first of all, we need to define what a segment is. So a segment is a part of a line with endpoints. And the way that you name this or label it, it's named by the two endpoints. And the two endpoints are just 2 points. So, for example, M, N, and you draw that just with a line across the top. So notice how there are no arrows as there were with our lines. So the way that would look, you have 2 endpoints, M, N, and then you connect those 2 endpoints. So can you find the length of a line? Yes or no? No, you cannot. Why not? Because it extends indefinitely in both directions. So remember in the last lesson when we talked about a line extending both ways. So now, can you find the length of a line segment? Yes, because it has a start and an end. So we're going to find the length of segment AB in the diagram below. So A is starting here at 0, and B, looking up, you can see comes down to about 3.7 centimeters. So notice that there are 10 little tick marks within each of these, and that here's our 5 and then 6, 7. So it's a little hard to see, but if you get close and look. Now we want to find the length of segment RS. So R again is starting at our 0, then S comes up here, but notice that there are 16 in here, 16 little dash marks. So we go up to the 5th one. So we have 1 and 5/16 inches. So just like using a ruler, you want to see how long that segment would be. So now we're going to talk about betweenness of points. So we have a line here, line RT, and we have S is between R and T. So notice that R and T are on both sides of S. So now we're going to talk about finding lengths of segments without having a ruler. So find the length of XZ in the diagram below, given that XY is 4.5 centimeters and that YZ is 3.2 centimeters. So we want to find XZ. So segment XZ equals segment XY plus segment YZ. So we're going from XY and then we're going to from Y to Z. So segment XZ equals our 4.5 plus our 3.2. So segment XZ equals 7.7 centimeters. Now, suppose we're not given actual numbers. Already picture this time. So, find X and ST if T is between S and U. So we have a segment SU and T is between S and U. Now it tells us that ST is 7x and that SU is 45 and that TU is 5x minus 3. So from the previous question, we know that ST plus TU gives us SU. So I'm going to say that again. Segment ST plus segment TU equals segment SU. So now substituting in the measures that it gave us, we have 7x plus 5x minus 3 equals our 45. So now combining like terms, we get 12x minus 3 equals 45. Adding 3 to both sides, we have 12x equals 48. And then dividing by 12, we get x equals 4. So now that we have our x, we want to find x and st. So st is equal to 7x. So then I can take st equals 7 times 4, which equals 28. So segment st equals 28. So now we're going to talk about what it means to be congruent. So congruent segments. In this example, we have segments MN and QP. And so we have that MN is congruent to QP. And this symbol right here means is congruent to. So the little squiggly with the equal sign underneath is congruent to. And it's because segment MN and segment QP have the same measure. So the measure of segment MN is 2.1 centimeters and the measure of segment QP is 2.1 centimeters. So now moving on to lesson 1.3, we're going to look at distance and midpoints. So to find the distance between 2 points on a number line, as shown here, you take the absolute value of x2 minus x1. And order is not important. So it doesn't matter if you take x1 minus x2 or x2 minus x1. It's not going to make a difference. So find the distance from point A to point C. So point A is at -5. Point C is at 0. So we get the absolute value of -5 minus 0 equals the absolute value of -5, which is just 5. Now we're going to find the distance from B to D. So B is at -2 and D is at 2. So we get the absolute value of -2 minus 2 is the absolute value of -4, which is 4. So again, just like in the previous videos, if you're watching this and it's going too fast, make sure you're pausing, rewinding, taking notes as you go along. So now we're going to look at the midpoint of a segment. Midpoint stands for the middle. So that means that the distance on both sides of that point are the same. So in a number line, the formula is x1 plus x2 divided by 2. So it means it splits it in half. So what is the midpoint of F and H? So we have x1 is -3 plus x2 is our H, is our 5 divided by 2. So you get -3 plus 5 is 2 divided by 2 is 1. So our midpoint actually turns out to be G. Now I want you to notice that we go 1, 2, 3, 4, and we can get to H. And if we go to the left, we go 1, 2, 3, 4, and we can get to F. Therefore, G is our midpoint. Now, we want to find what is the midpoint of GH. So, G is at 1, H is at 5, and then we're going to divide by 2. So we get 6 divided by 2, so our midpoint is 3. And then again, you can count that out, that 3 is 2 away from 5, and 3 is also 2 away from 1. So now we're going to look at finding distance between points and on a coordinate plane. So the formula is given for you there. The d equals square root of x2 minus x1 squared plus y2 minus 1 squared. This should look familiar, kind of like the Pythagorean theorem. So we're going to find what is the distance from point F to point H. So point F is at 1, -1, and H is at 6, 5. So we can take our formula and say it's square root of 6 minus 1 squared plus 5 minus a -1 squared. That's going to give me square root of 6 minus 1 is 5 squared plus 5 minus a -1 is 6 squared. So I get square root of 25 plus 36, so the square root of 61. Now, I mentioned the Pythagorean theorem. Let's look at this. We can draw a triangle with F and H as points. So our bottom here, you can see, is the difference between our x values, and that was R5. And then the y is the difference between our y values, and that was R6. So then you can use the Pythagorean formula to find your hypotenuse or C value. Now we want to find the distance from point G to point F. So point F, we said, was at 1, -1, and G is at -7, -1. So we have our square root of 1 minus -7 squared plus -1 minus our -1 squared. Give us square root of 1 minus a -7 is 8 squared. -1 minus a -1 is 0 squared. So that gives us the square root of 8 squared, which, as some of you might know and be able to go straight to, is just 8. But I'm going to write the square root of 64, and then that goes back to 8. And then notice that our y values here are the same. So this is kind of the same thing as going on a number line. You're just going straight across, and you can see that that's 8 units. So again, we already found the coordinates. G is at -7, -1. F is at 1, -1. And H is at 6, 5. But now we're going to talk about midpoints in a coordinate plane. So the midpoint on a coordinate plane is found by x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So the midpoint of FH is going to be at +1 plus our 6 divided by 2, and then our -1 plus our 5 divided by 2. So you get 7 divided by 2 and 4 divided by 2 to give you the midpoint of 3.5, comma 2. And that makes sense because if you think about going 3.5 and then up to 2, it's about right here. And that's the midpoint. And so you can imagine the two triangles in here being the same. Now we want to find the midpoint of GF. So we have the x values, -7 plus 1 divided by 2, and then -1 plus a -1 divided by 2 gives you -6 divided by 2 and -2 divided by 2. So this is going to give you -3, comma, -1. So that's at right about there. And notice, again, the y value is -1 because both G and F have the same y value. So thank you for watching that lesson. Please rewind and rewatch. Make sure you have all the notes, and good luck on the practice.